This is George Boole. George Boole is a mathematician and was the founder of the modern tradition in algebraic logic. We're going to build an example here to illustrate the case. We're going to evaluate two conditions. Each condition can be either true or false, and we'll use an example to explain it. Let's say condition A is the state of whether or not we're hungry, and condition B is whether or not we have food. Based on those two conditions, we're going to make a decision as to whether or not we're going to eat. In the first row, you'll see we're not hungry and we have no food. Therefore, we're not going to eat. We are not hungry and we have food. We're not going to eat. We are hungry and we have no food. We're not going to eat. If we're hungry and we have food, we're going to eat. Let's take a different example. If you go to the store, they say cash or credit. So you say, I have no cash and no credit. You don't eat. You have no cash, you do have credit. We're going to eat. You have cash and no credit, you can still eat. And if you have cash and credit, you can eat and eat. That's fundamentally what Boolean logic is. It keeps going. There's something called the NAND case, which is the negation of the AND case. If you look at the values in the AND column and just negate them, you get the negative case. And as you get into programming or other decisions, you'll start thinking of examples where you negate the AND cases. Similarly, there's a NOR case, which are just the negations of the OR case. In computer programming, we use Boolean logic extensively, all the time. This is an example of C code. In an if statement, what's in the parentheses will evaluate and eventually produce a Boolean answer of either true or false. And it's that true or false condition is what determines the execution of the next line, the do something cool. If condition, do something cool. If condition is true, you do something cool. Otherwise, you just continue on. This is a compound statement, so we evaluate condition A and condition B, and if A is true and B is true, then we'll execute the do something cool associated with the first if. The second line is a NAND case. If we evaluate condition A to be true and B to be true, it's A and B negated, then we will do that one. The double ampersands are the AND operators. It's the Boolean AND operator. It's testing if condition A and B is true. Go down to the third set. We have condition A or condition B is true, then what's in the parenthesis will evaluate to be true. The last case, you start from the inner parenthesis and you work out. So the inner parenthesis could be A is true or B is true. You negate that result, and then if that result is true, then you execute that last line. You evaluate these conditional expressions from inside to out, inside the innermost parenthesis to the outermost parenthesis. The double ampersands are AND conditions. The two vertical bars are OR conditions. If you wanted to do a evaluation and just store it somewhere, we could create a variable called indicator of thing. You've probably seen declarations of integers, doubles, floating point numbers, character strings, and other types of things. There's a Boolean operator called the bool. It's a data type, and we can create a flag that can only be true or false. And it was named after, guess who? George Boole. So in this case, we're going to evaluate what's in the parenthesis, determine if it's true or false, and assign it to the variable called indicator of something. Boole, named after George Boole. George Boole wins the logic contest. He's watching what you do. Do good work.